Hello, everyone. Welcome to CES 2026. I'm here joined by Spencer Huang, who is the product lead for robotics at NVIDIA. We're going to get a quick update from Spencer on Cosmos and Groot. But before we do that, Spencer, could you introduce yourself and tell us more about your role at NVIDIA?
Sure. So I lead the robotics product software division. So we cover everything from the technologies to generate synthetic data for robotics to the simulation stack like Isaac Sim, Isaac Lab, Cosmos for robotics, as well as Project Groot. And so we cover everything from data all the way to deployment, including the middleware foundation, the middleware frameworks, how we're optimizing all these models to get on device, and then putting in that.
That sounds like a very important role. I'm glad I have you here with us.
Thank you.
You know, we met at GTC last year. It has been almost a year. So tell us more. What have you learned from Cosmos and Groot? At the time, it was totally new. And what have you learned?
Last year was a really exciting time for robotics because the first, so let's step back 2 years, right?
Yeah.
2 years ago, we really started to see that ChatGPT moment for robotics was starting to come in. And what that meant was we could start using these video language models, these VLMs like Cosmos,
Yep.
to start building out these VLAs, these video language action videos that we could apply to robotics. Now, the concept of it was born, a couple of years ago, but last year what we really focused on was how are we going to be getting data and how do you set up the pipelines for all the training? And so last year was really about doing clinic. How are we going to set up the infrastructure for training large-scale VLA models? How are we going to set up pipelines for generating large-scale data from data that we collect? Because we know that we can't collect enough. There's not enough humans or time in our lives to be able to capture every type of task and object and environment. And so we really wanted to set the groundwork. This year, what we're seeing is that Cosmos started as a means for us to augment data, meaning that you could take real data and you could paint the background different, you could change the materials inside of those frames, but it wasn't necessarily being used as a role model. It was being used more as a data augment. Now, what we're going to be seeing now is using Cosmos as a role model so that way we can evaluate things. Because Cosmos as a role model means that it represents the world in a way that it's been learned from. And so it can infer and start generating the results of actions within a space. So I don't have to be creating these 3D environments in Omnibus and I could use the Cosmos scripts. Now, another exciting thing for Cosmos is how can we use it to train analysis? And so now Cosmos becomes not only a way for us to augment data, but to become a neural simulator. And so now we have two types of simulators that we get to work with. One, which is Omniverse, very physically grounded. And we're building Newton for robot learning. So that way we can have accurate physics for rigid and soft body dynamics, the types of things we can do for very dexterous tasks. And then you have Cosmos for diversity. How can you use natural language to actually prompt environments and scenarios and edge cases that would otherwise be too hard to do in a traditional 3D environment? And so between the two of these, I think we're going to be unlocking a lot of the robotics data flow.
Yeah, that's a significant breakthrough, right? I do see the robotic, the ChatGPT moment, the robotics is absolutely here. Kudos.
He was that amazing job.
Absolutely. So let's talk about the product line, right? From the product line perspective, what has Groot is powered into the production state?
Sure. So when we think of robotics, Groot is a way for us as a company to understand what is necessary to train a fully autonomous model. But we don't expect that the model itself today is ready to go to production. However, all of the pipelines and tools I just mentioned for capturing data, generating data, simulating the environments and trying to train these policies, these are all tools that we can now use in production today. While the models are still being understood and researched and trying to be refined. So things like data generation, I think this is where most of the industry can pick this up and use it like relatively quickly. Omniverse was wonderful for domain randomization of objects in a 3D space. So if I have a table and I want to randomize where I'm placing an object or the size or the color for perception models back in the day, it was really great for that. But once you started to get to things for mobility and navigation, it became relatively tedious because you had to recreate all these new environments. And so it's much easier for us to be able to do this with Cosmos. And I think that what that's given us is the ability to take these technologies and apply it to today's problems. So for instance, you're an industrial warehouse. There's a lot of areas where it's relatively unstructured. It's not fully structured. Things are all over the floor and lighting is different. These are all things that you can now use Cosmos to improve your perception to increase the accuracy of existing models or to even train out perception models that you weren't able to do before. And so we're starting to see a lot of improvements for video language navigation models, VLNs. And these are end-to-end models for mobile robots that aren't doing any kind of manipulation with their world. They're just doing navigations. And so I think that this is an area that's prime for leveraging these technologies. And the same for pick and voice, very general types of grasping and dexterity workloads. I feel that our technology is good for training out these limited scope policies. Groot itself is going to be a long-term vision, and we're seeing great progress, but it's still in progress, right? It's not fully ready for flat public.
So 2025 has been transformative, right, for media and for everyone who is in this space, right? We talk about Cosmos Rhythmic, right? It graduates on Algorithm ChatGPT 4.0 and Tafa that 1.6 with the full body control. That's just significant breakthroughs. But in terms of real world, right, application, what pathing will kind of customer really leverage to really change their economics or capabilities?
Sure. So if we look at the models themselves, right, Cosmos is ready to be deployed. If you want Cosmos Reason for evaluating what's happening inside of a large space, you could use something like visual surgery summary, which is something leveraging Cosmos Reason through just the exterior of an environment, so something like a smart space. But for robotics, where you have things like an onboard humanoid, for instance, if you actually want to use the reasoning tool, I think we're still just starting on that path. And the reason I say that is because the reasoning that you need in order to do long horizon dexterous tasks is different than having reasoning to understand what's happening in a sea, right? Because you're reasoning about what's happening versus about what needs to be done. And then what needs to be done is different than how you're going to do it. And so because of those three areas, I think that Cosmos Reason is great when we're putting them into environment staging. And it's especially awesome for when you're trying to kick off your data flywheel. One of the things that we're going to run into very quickly with robots, last year you saw that lots of people were trying to find ways to capture data. And in the process of that, they created many new technologies to capture the data, different types of onboard sensors and whole body sensors. So that way they could track for their specific embodiment or maybe more generals. Because of that, this year, we're going to see an influx in all this new real data that's coming in. And because of that, we're going to have a huge opportunity to generate lots of synthetic data. But you're going to have a big data problem. You need to be able to differentiate between duplicate data and really edge case unique data, right? And this is the same as the big data problem we had 6, 7, 8 years ago, when people were just capturing as much data as they could, but they had no means of ingesting and filtering and curating. And so Cosmos Reason gives us a huge capability to be able to do this, which really offsets the overhead that data scientists had in the beginning of LLMs, having to deal with their data clause. And so for us, we're taking that and looking at how can we leverage reasoning inside of the data flywheel. And this is where I think a lot of the industry can pick this up today. They have to, because once we start getting the data flywheel going, the skills training going, the ability to deploy these robots into factories is less about the base model, and it's more about what is the unique value or what is the unique task that you needed to do in war industry. And then where's the data that helps train and post-train it. And so capturing that data today is extremely crucial if you want to be able to leverage the technologies that are coming out in a year or two right out the gate. And so I think a lot of it is Cosmos, setting up your infrastructure correctly. This is something that's very highly overlooked. When you're training robotic systems, between DGX for training the VLA system versus using Omniverse or OBX for leveraging simulation soul, how you build out your data center infrastructure is because it's very different than training it all. And so looking at infrastructure, how are we building out the infrastructure? And then how are we incorporating Cosmos and then also Omniverse for data generation? I think these are things that people can take advantage of today, and they're proven through our work under implementation layer. It is. Yeah.
We do. So looking into 2026, what are the critical paths for action? Why wouldn't it happen to be true for physical AI?
There's 2 or 3 areas. The first area is in the data collection. We're not sufficiently, I don't think that we're sufficiently advanced enough in some of our generative technologies to offset having to capture real data. Over time, I think the need for capturing real data will of course go in. But for now, we need lots and lots of real data. And so I think what we're going to see this year is a huge influx of data capture. The second thing that needs to happen outside of the data is, just like I mentioned, we have to have a data flywheel. When you capture lots of data, you need to make sure that you're you're curating it so that way you can generate more data that's useful, because it's very easy to generate lots of data that's not useful. And so it's a bit of an art more than a science. And so I think that between setting up the real data farm and then also being able to turn that real data into part of the data flywheel for synthetically generating or augmenting the data needs to be unlocked this year. And that's all infrastructure. The other bit is, I think there's a shift in how people are approaching simulation. Simulation is, for, let's take reinforcement learning or imitation learning, either of those really great for this end-to-end generalized human autonomy that we're trying to get there. But when we look at industrial robotics, I think you can still leverage that for very small specialized tasks, things that you can't actually program today, but things that are not fully end-to-end. There's this middle ground where you can't train a conventional robot to automate a process that's slightly too complicated, but it's also not complicated enough to warrant an end-to-end law. And so there's these specialized hybrid stacks that I feel are going to be extremely useful in 2026. They're going to set these companies up to be super successful when end-to-end models come, because they'll already have plumbing, they'll have the infrastructure, they'll have the data and the knowledge, did flywheel, right? And so all of this sets them up for success in the rest.
Yeah, so we're moving from specialists to generalists and job specialists. So that kind of a curve I'm seeing, and that one, it's encouraging to see the technology behind that is ready to make that transition.
Yeah, the nice part about what you mentioned, going from specialist to generalist, the only path is to capture enough data or to represent the specialist in order to train generalists.
Yeah.
And I feel that robotics is so hard. There's the basic skills, the skills that everyone is: grasping, holding, pushing. These are all general atomic skills. The hard ones are the ones that are going to be very unique to each industry.
Yeah.
And so they should start today.
Well, I was at Jensen's keynote Monday, and he talked about open source, or announced the Alpha Mare, and there's also 8 million dropouts from Hugging Face. So isn't that against the moat strategy and the scam game here?
It's actually directly in line with our strategy, and the reason is because NVIDIA is a platform company. We're here to lift the ecosystem. We love building full stack, and then we modularize it so that way you can take what you want and leave what you don't need. We just hope that you're using something. But fundamentally, the need for GPUs and our accelerated computing stack, that's mostly where our unique value lies. But for robotics, for instance, when we're training these models, the model isn't something that we want. We're trying to compete with Pi Zero and these. I want to help them succeed. But what NVIDIA does is we start getting very, very deep vertical in order to understand what the ecosystem needs to push state of the art. So that way we can co-design our hardware to make it apt for this. That's how we were successful with LLMs. We had to train an Nemotron in order to understand what it would need, and then push that boundary so that way the hardware is there when the research is ready and we need a scale. And so the same thing in robotics. The more open source, the more open we are, the more that the ecosystem can take our work and leverage it for their own needs, and then they can contribute there. It's completely infeasible in the robotics space to assume that one company is going to solve, because we have to represent the entire world. And it's not just the topical. It's going to be everything in the air, everything underground, everything in the water. And soon, we're going to, space robots are coming up pretty quickly.
Yeah.
And so one company can't possibly cover that much ground. It's like asking a single company to cover the whole universe. It's actually up to humanity to do this. And so we really need the entire ecosystem to work together on both AD and on robotics. It's a human problem, not a unique individual company.
Yeah, we all appreciate that, by the way, right? Extreme co-design approach, and then also really supporting the strong trading a strong ecosystem. To me, that's really the long day. But I'd like to talk. I learned so much from you today. I'd like to ask one more question here, and getting into from product perspective, what bet are you putting on in 2026 and beyond?
So in 2026, I'm super excited for concepts. You're going to hear this a lot, and you can see the ecosystem shifting towards world model initial policies. And you can even see this with things like Alphamaya. Alphamaya, we like to look at the autonomous vehicle industry and robotics and say, well, you guys are 5-6 years ahead of us, because it was so much easier 5-6 years ago to say, well, what's an autonomous vehicle? It's a self-driving car. Everyone kind of wraps their head around it. When you say robotics, general robotics, it could be any air. And so it's very hard to say, well, where do you start? And so AV is kind of a little bit of a glimpse into the future for what we can do in robotics. And we definitely see there's huge immense value to leveraging role models to initialize our policies. And the reason is because these role models are not just operating semantic. They're not just saying, I'm using language that's going to interpret this and then try and convert into action. But you can have role models that are actually trained on action. So you can have them trained on the same type of input that we would need the robot to take, which is contact and visual character, all perception data, and then output actions through that. I think this is a wonderful path, and we're going to have Omniverse and Cosmos. They're like siblings; they have to grow up together. Cosmos has the luxury of being diverse, but it's not physically grounded, and it hallucinates. And so manipulating a ball might turn it into 3 oranges. Whereas Omniverse is extremely physically grounded because we want our physics to be extremely accurate. So that way, this high fidelity can be used as a drop-in for reality or testing a card deformer. The problem that you run into is it's very complicated to set up those environments, and so you don't move as fast. And so between the two, you get physical grounding and diversity. And this is really what we need as we start trying to get towards the data generation problem, as we're starting to solve for our policy evaluation. You can't create every environment or every use case, so you have to, using natural language is going to give us a huge step up. So I think, these role models are going to change a lot for robotics.
Yeah, thank you so much, Spencer. We certainly have reached an inflection point with robotics, right? And then kudos to all the work you and your team are doing at NVIDIA. And hopefully I'll catch up with you soon at GTC.
Absolutely. See you in a few.
Thank you.
Thank you.